Let's assume you are watching this sitting on your couch. From your point of view, you might seem to be stationary, but you are actually not. As scary as it might sound, you are moving with a speed of 30 kilometers per second right now at this moment. Heliocentrism is the astronomical model in which Earth and planets revolve around the Sun as opposed to geocentrism, which placed the Earth at the center. In 1543, the Renaissance mathematician astronomer Nicholas Copernicus detailed heliocentrism, leading to Copernican evolution. In the following century, Johannes Kepler introduced elliptical orbits, and Galileo Galilei presented supporting observations made using a telescope. With the observations of William Herschel, Friedrich Bessel, and other astronomers, it was realized that the Sun was at the barycenter of the solar system and not the center of the universe, which explains why we have aphelion and perihelion. About 4.5 billion years ago, waves of energy traveling through space pressed clouds of hydrogen, helium, and remnants from the violent death of stars closer together, and gravity caused them to collapse in on themselves and start to spin. The spin caused the cloud to flatten into a disk. In the center, the material clumped together to form a protostar, which would eventually become the Sun. The material in these clouds is in constant motion, and the clouds themselves are in motion, orbiting in the aggregate gravity of the galaxy. Planets form from material in this disk through accretion of smaller particles. The Sun itself rotates slowly once in a month. All planets revolve around the Sun in the same direction and virtually the same plane. In addition, they all rotate in the same general direction with an exception of Uranus and Venus. This rotation can be described as angular momentum, a conserved measure of its motion that cannot change. Another reason for the question, why the Earth revolves around the Sun, has a lot to do with gravity. We all know this one formula from high school, that is F equals gm1 m2 by r square, which in short, the heavier the mass of one body, the more gravitational force it exerts on the other body. Since Sun is the heaviest celestial body in the solar system, the gravitational pull of Sun keeps pulling Earth and other planets towards it. Literally, we are freely falling into the Sun all the time, but we keep moving so fast that we keep missing it. That's what an orbit is. Think of it like a merry-go-round. The farther and farther you are thrown away from the center, when it slows down, you lose momentum and fall back inwards. In addition to gravity and angular momentum, the stability of orbits contributes to this beautiful astronomical perfection. But why is an orbit stable anyway? Well, that's a story for another why. Thanks for watching.